We are covering 3 core geotechnical topics for the FE civil exam: lateral earth pressure, bearing capacity, and slope stability. All the formulas discussed can be found in the geotechnical section of the NCEES FE Reference Handbook. First, let's focus on lateral earth pressure, which is the horizontal pressure exerted by soil. There are 3 states to know. The at-rest state, denoted by the coefficient K0, applies when a retaining structure is rigid and does not move. The formula for normally consolidated soil is K0 equals 1 minus the sine of the soil's friction angle, phi. The second state is the active state, which occurs when the wall moves away from the soil, allowing the soil to expand and reduce its pressure. The active earth pressure coefficient, Ka, is calculated as tangent squared of 45 degrees minus phi divided by 2. The third state is the passive state. This happens when the wall is pushed into the soil, compressing it and mobilizing its maximum resistance. The passive coefficient, Kp, is tangent squared of 45 degrees plus phi divided by 2. A common exam trap is confusing active and passive conditions. Here's a mnemonic to keep them straight. Active pressure happens when the wall moves away, and it's the smallest pressure. Passive pressure is when the wall pushes into the soil, creating the largest pressure. For a soil with a friction angle of 30 degrees, Ka is 0.333, while Kp is 3.0, a significant difference. Next, we'll examine the bearing capacity of shallow foundations, governed by Terzaghi's bearing capacity equation. This equation calculates the ultimate bearing capacity, Q-ult, and has 3 main components: cohesion, surcharge, and the footing geometry. The formula is Q-ult equals C prime times NC plus gamma times the footing depth D times NQ plus 1/2 gamma times the footing width B times N gamma. The bearing capacity factors NC, NQ, and N gamma are non-dimensional and depend on the soil's friction angle, phi. You will find these values in a table within the NCEES Handbook. The biggest trap on the exam is unit consistency. Bearing capacity is a pressure, like pounds per square foot or kilopascals. Ensure that your soil unit weight, gamma, and your dimensions B and D are in a consistent system, such as feet and pounds, before you calculate. Also, distinguish between ultimate capacity and allowable capacity, which is just the ultimate value divided by a factor of safety. Finally, let's discuss slope stability. For the FE exam, this topic is tested conceptually through the factor of safety. The factor of safety is the ratio of resisting forces to driving forces. You will not be asked to perform a complex multi-slice calculation. Instead, a question might ask how an increase in pore water pressure affects the slope stability. Increased water pressure reduces the soil's effective stress, which in turn lowers its shear strength and decreases the factor of safety, making a failure more likely. The driving force is the component of the soil's weight acting parallel to the slope, while the resisting force is the soil's shear strength along the potential failure surface. A typical minimum factor of safety for a permanent slope is 1.5. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.